This lesson is a very short lesson on graphing data. It's going to be on this topic called scatter plots. You've probably seen these in other courses, maybe science. You've probably done a scatter plot. Maybe you didn't even know that's what it was called. Basically, it involves plotting points and making what's called a line of best fit. That's not really part of this course. You're not going to be given data that doesn't have a perfect relationship. You'll see what I mean in this example. It's actually not even a scatter plot. It would be more likely what we would call a linear relation and making a line. Okay, a scatter plot, the data when they're graphed might look something like this, and we would say, well, I think this is generally a pattern like that. Or we might see a bunch of dots that are going something like this, and we would say, I think the pattern looks like that. That's a scatter plot. The points are random, and we're trying to see if there is a relationship between the points. Okay, it's a graph that displays two variables and tries to show that whether there is a relationship or not. This one would be a relationship. This one would be also a relationship. Something that would look like this, you might say, I don't think there's a relationship there. I don't think the two variables are related. Okay, so quick review on what these terms mean. Discrete data means data that can only take certain values. We would not draw a line there. Continuous data means data can take any value within a range. For example, time is like it just keeps going. If we have 1 minute and 2 minutes, you could also have a minute and a half. Okay, that would be continuous data. Okay, points on a graph are joined if the data are continuous, and points are not joined if the data is discrete. Okay, so that's information for questions that we'll see. Let's now do an example of a scatter plot. And as I said, this is actually a linear relation. You're going to see what I mean. Okay, so air temperature, speed of sound. Usually when in doubt, we're going to let the first one be x and the second one be y. So this means that the speed of sound would depend on the air temperature. Okay, so I guess the warmer it gets, the faster the speed of sound is. So if we graph this, let's go 5, 10, 15, 20. And then instead of starting at 0, I'm going to put a break in the graph here, and I'm going to start at, let's start at 330. Okay, and then I'll go to 335, and then 340, something like that. Okay, so our first piece of data is at 0, the speed is 331, so I'm going to put a dot there. At 5, the speed is 334. At 10, the speed is 337. At 15, the speed is 340. So it looks something like that. Maybe I got that dot. Something like this. Okay. And so I can see what the independent and dependent variables are. And then I'm asking myself, should I draw a line here? Should I connect these dots to form, it's actually a straight line. I'm sorry, I didn't draw it very nicely, but I should have drawn this just a little bit differently so that it shows that it's a straight line. You can see it goes up by the same amount every time. So why would I connect the dots? Well, I could have the air temperature being between 5 and 10 degrees, say at 8 degrees. All right. I could have the air temperature be, say, at 17 degrees. Okay, this is continuous data. And if you see, our dots actually form a perfectly straight line, not a semi-straight line, not approximate. This is actually what we call a linear relation. And that's going to be our whole next unit. Just know that the scatter plot basically involves plotting the points and then analyzing the data. Okay, there's a really, really short exercise for you to do. I believe it's exercise 28. It shouldn't take you very long. Very quick lesson. Okay.